Hello, Southern Alberta CADers. Actually, all of Alberta CADers. We've got some Northern Alberta and other places in here too. You'll notice that I haven't been around much in the last little bit for some of the CAD things. You've got some of the skills you need to go through the next few after those first few weeks. And on top of that, I kind of sent myself down a rabbit hole with the week 3, the gripper project. And I know at this point we're probably a couple weeks ahead of that, but I wanted to show you what I came up with. Now, everything that I did here is based off of skills you had from the first couple weeks. You'll notice that a lot of the light blue on this one, and this is just my my gripper demo. Everything that I did in blue is actually just 3D printed. Everything that I did in, there's a couple white and black ones in there, but everything else is just a stock part. We've got our basic Tetrix servo block over here, same thing down here, except I've attached it to something that's a little bit weird. Some of our friends over at Studica actually sent this over. This is going to be their linear slide kit, and I've been told that this should be available towards the late part of the spring, and for sure for next year's FTC season. This is kind of a cool thing, and I'm just going to show you this one. It actually has a tooth pulley at the top. It actually has a tensioning knob, so you can very easily tension that system, and those two things actually run down into this bracket down here. And I'm going to assume that this is some sort of hard plastic in order to make this work. You'll be able to clip your pulley into here, and then you'll see that this whole thing right here actually lifts itself up and actually will slide along that rail, allowing you to move this with a servo on the bottom. And this is a cool idea. I think this is going to actually be something that we very much could use. I've actually attached a few pieces to it, tried to keep the weight relatively down, but I want to talk through the design that I put together because it uses some CAD skills you have, but it also uses some design skills that you should use. Now, when talking about how to manipulate a game piece in any FIRST Robotics game, one of the things you want to keep in mind is, how am I going to get this to my gripping mechanism? We had some great grippers in the actual CAD challenges, and the grippers were really good, but a lot of them, and this is a problem I see with a lot of especially rookie teams, will create a gripper that involves them chasing the game piece around the field. It's always better in a robotics game to actually create something that has an intake. Now, an intake can have two forms. It can be passive or active, and we're really familiar with the active intake. Wheels to pull an object in, or a roller with surgical tubing to actually pull an object towards you. But this one actually takes advantage of a passive intake mechanism in the sense that this ring actually is going to fall into this 3D printed part, and it's going to be able to sit pretty much exactly here. I've built the 3D printed part to be about a millimeter and a half wider than the ring, so that as soon as you drive into this ring, you're pretty much set. And because everything's servo-based, you can actually just drop this whole mechanism down into the middle of the ring. I'm actually going to take a top view here just so I get the thing lined up properly. In real life, you'd have a little bit of a time here trying to make sure that everything got where it was supposed to be. Now let me show you what I've done here, because this is kind of cool. With the ring sitting naturally in here, and you'll notice I used the Tetrix kit bot. In reality, this whole mechanism would go on top of, on the front of a robot with level wheels, and this whole thing would sit flat and we'd be all good. But in this case, if we slide this ring in, we are able to drop our mechanism directly into the middle of it. There is no chasing at all. You simply drop the mechanism in, life is good. And it's often really easy if you can get the game piece into your robot. Now, we built the linear slide, linear slide in this case. I've also got one servo here to move this thing around, and as of right now, I can't actually move the ring with the animation I have, but I want to show you the gripper, because as soon as this gripper drops down and this servo here activates, something really neat happens. I'm going to drag this up, and I'm going to show you the full claw mechanism. I'm actually going to swing this out here because it is on a rotational swing. This will allow you to actually throw the ring out in front of you and potentially drop it. Oop. Cancel there. Now, in order to show you how the gripper works, I'm actually going to zoom into the bottom of the gripper, and I'm going to very simply take the gripper body, and you'll notice that I've actually named all of my parts down here in my browser. This is relatively good, this is generally good form to try to keep it so you can find stuff that you need. I'm going to ground the gripper body. That just means it can't move. It's stuck where it is. Now, you notice what I've done. I've created all 3D printed parts here, and in reality, this bottom part of the gripper and the top part, they'd probably be two separate parts that we'd bolt together in some way, shape, or form, just because of the amount of overhang we have here, but that's a minor thing. We're just prototyping at this point. Basically what happens is, we take our Rev servo, or any brand of servo for that matter, and we drop it through here, and I've used a simple Rev aluminum servo plate here, just to make sure this works. All of my joints in this case would use some version of an M3 screw, bolted in. I haven't worried too much. A couple of these would need countersinks to make this work properly, but basically, this allows this servo to move. Now you'll see that when I move the servo, these linear, I think I've named them slider arms, are going to allow the outsides of this plate to move. And if we zoom around to the bottom, we can see the whole mechanism in action. There we go. We can actually see that as we turn this, we're going to get movement in and out. This is going to allow us to grip that ring. You'll notice that I've made these aren't perfect rectangles. There's a little bit of a lip along the bottom. Zoom in and see, there we go. A little bit of a lip along the bottom so that when these move, grab my wheel here, you can see they move out and they would be able to grip the bottom of this. Some teams would also use things like foam tape or things like that to do this particular maneuver. Now everything here was based off of sketches of other parts in the design. So you'll notice that when I move the ring here, just to test my dimensions, that the gripper itself it's about 2-3 millimeters smaller than the actual ring. But what happens is as soon as I drop this gripper down into the ring, I'll be able to expand these out, put pressure on 3 sides of the ring, and make sure that I can place it exactly where I need at any point. And this is part of that design process, is asking yourself not just how could I pick up that ring, but what is the most efficient way to pick up that ring. Your first robotics match, FTC especially, you have 2.5 minutes to actually get through your match. And if you can cycle 1 or 2 times faster than your opponent, you're probably going to win more matches than you lose. And in this case, this makes it easy. Drive into your ring, very simply, drop it into your passive intake, move your gripper. Can unground this now. Move your gripper so that the thing, there we go. Move your gripper so that it drops down in, and have your servos preset so that you have buttons already set so that you can drop this thing down. And expand your gripper out, and off we go to the races. Lift it up, move it out, drop it wherever you're going. Easy enough. And that's the design process that you really should be looking for. The idea that you should have that multi-part potentially linkage between a passive or active gripper, some sort of gripper for the game piece, in a way that it really can't miss. With that being said, good luck on whatever challenge you're on. I know the next week challenges we've already started looking at in terms of a shooter. Good luck, stay safe, and have fun.